Hello everyone. Welcome to this new video that will delve a bit into a new parser generator for Rust. This parser generator is called Parol. My name is Jörg and I'm the author of Parol. First, I would like to introduce you to the features of this parser generator. I will then provide some tips for getting started and getting your working environment up and running. First, we need to install Parol and Parol language server. For this, I use the cargo tool. So now we should be able to call Parol from our command line. You can check it. Next we install is the language server, as I said. Should be also very easy. And we could also check the version of this, and it's probably, yeah, everything is fine. Now we are able to use Parol, for instance, to create new projects for us. I would like to introduce you to Parol with the help of a small example project. I found a good idea, I think, in the Wikipedia on a site that describes resource description frameworks. Sorry for the site being German, but this is not so complicated, so I can explain everything. The idea is that we have a text information representation of a knowledge framework, and the representation is a simple triple has a simple triple form. It is created from three parts: subject, predicate, and object. And all the information that are given from a text file can be parsed, and maybe we can transform it into another representation. This is the basic idea behind my simple example. So everything that is more detailed will be explained later on. So let's start with creating a new project. We use the Parol new subcommand. Um, there are several options you can give here, but first, and for this example, we use a very simple template that creates a binary module, meaning you have at the end a tool that is executable from your command line. This is everything we need to instruct Parol to do this. The name of the grammar is deduced from the path name that we'll use for creating it. So the grammar will, in the end, be named semantic triples. Okay, let's do this. So you can see a new folder was created by Parol. And also the initialization of a Git repository has been done. What we can do next is we can build our new project. So having that done, we can switch over to our editor. So in Visual Studio Code, if it happens you use it, I would recommend you to install the Parol VS Code extension. This will help you in your workflow when you edit your grammar, and you will be supported by it in several ways in combination with the language server. Okay, let's have a look at the structure of the project. There is nothing special. Um, what needs to be said is that the template created a simple empty grammar in the Parol style, let's say. And we have a build script that is used by Cargo to generate the sources from the language description. Okay, since we have here the normal empty grammar, there is nothing we can do. We can perhaps make our first test if the text here, which adheres to this grammar, could be parsed, but this is very, very simple. But anyway, we can do this. Yeah, this worked. The the behavior that is introduced in this example or is created during the creation of this template is that the parse result is printed to the command line. So actually you see that the parsed structure here in form of tokens and so on is parsed out, is printed out. So let's change the grammar. Maybe first we can modify our test text file. Yeah, you may recognize this from the Wikipedia site. So the aim is to parse this structure, and we modify our grammar here in this grammar description file. Okay. Semantic triples, as I said, is, or as you can assume, is a list, or maybe an empty list of single triples. So this is the first step. We have list specified by using these braces here. And we define our semantic triple structure. Try this a little bit. Don't distinct between object here, only for the sake of simplicity. And we have to define the ID too. So I use here the regular expression feature. Yeah, and the predicate itself is built up from three parts. The double minus here and the ID of the predicate and the arrow here. So I will it in this form here. What is special on this notation is that we have here the appended the such a circumflex symbol. This means that the token that is parsed here is omitted from the generated data structures. Simply, we don't need them, and they are only syntactic sugar. So this should be everything we have to do to create this grammar. And what we can do is we can reformat the document. This is a feature that brings the language server to us. And we also can see the structuring of the project here. You can jump to such things and you can maybe rename or something like that. And jump to the definition when you go over this and you hit the F12. You will go there where it is defined. This is not so useful in this small grammar, but if you have a grammar with hundreds of lines and non-terminals and productions, it would be very helpful to can do this. Also, you have the possibility to hover over a non-terminal, and you will see the definition in the window here above it. Okay. We reduce this here to have more place here for us. Now we can build this actually using the run command. And voila, everything seems to work. We have nothing done yet, but defining the grammar and changing the tests information. And it was able to parse it. How can this be? This is the magic of Parol. Okay. We have now used a feature that I used to call prototyping for a grammar. This means that you can very easily and very fast create prototypes of your grammar and test it before you even start to process anything from your parsed information. The language processing is separated strictly from the language definition. This is a very strong paradigm of Parol. You don't have to mix language processing code into your grammar definition. So where is the magic? Okay, we should have a look at two generated files that are generated by Parol. Okay, first we could have a look at the parser. The parser, I don't want to delve too deep into the details here. It isn't very complicated, but maybe I should start with another explanation. The first thing that Parol does when it starts to parse a language description in such a par grammar file, it tries to canonicalize this grammar. This means that constructs that are recursive or loops or optionals or groups are transformed to equivalent representations. The result of this transformation can be seen here in this file that is created automatically with the suffix exp. But this is a transformed version of the grammar, which is actually equivalent to the original one, but without EBNF style extensions. The only EBNF style extension is here the repetition denoted by the braces. And this was transformed to a equivalent recursive transformation with these two productions, where one is the next iteration, and the other one is the end. So that's all for this. And now we can have a look at the parser. One interesting thing here is that Parol has generated deterministic finite automata for the decision making of which productions to choose next. You can see here that nearly all non-terminals like ID or predicate have case 0. Case 0 means there is no decision problem. There is mostly only one production with the name of ID, so you can choose this next. Yeah, you can see this here. This is the case. The only thing that needs a look ahead is the semantic triple list non-terminal. The semantic triple list is the special one I explained right before. And here you have to look what comes next, and you have to decide what production to choose from these two. This is done by this automata here. And yeah, this is very simple represented. You can see here the transition is a 4 tuple. It is the from state, the non-terminal, the to state, and the production that results from the transformation. Meaning that in state 0, when reading the token with the index 0, we go to state 2 and emit or decide for production 2. The other transformation is from state 0 with token index 5, we go to state 1 and decide for production 1. What does it mean? The token 0 is the end of input token. This means when we don't see any following token, we can decide that the grammar is at the end of its input. Then we decide to use the production 2. Here, the empty one. On the other hand, if we see the input token with the index 5, we decide for production 1. Terminal with the index 5 is the ID. And we can see here semantic triple starts with the ID. Then we can use production 1. This is the magic here in the parser. It is a complete automaton. So nothing is backtracked here. Okay. Now let's see the other file that is also created by Parol, the grammar file. The grammar file is more the interface to the user. It contains mainly the trait that is the interface. The trait is always named semantic triple, and then grammar trait. The grammar trait extension here or suffix means that your interface. And every function in this trait is bound to a special non-terminal. What does this mean? When a non-terminal is parsed and parsed completely, then the parser calls the function with that is bound to this non-terminal. The other feature that this generated file contains here is that all all data types are created for you. All data types that are concluded from your grammar are created automatically. You can see here the triple contains of the two IDs and a predicate in between. So this is yeah, the whole magic is that you don't need to do anything on your own regarding the data types you are using in your grammar. Everything is generated for you. So the actual language processing needs to be done here in a file that is also created by the template Parol new, and it has a standard form, and the standard form is that it implements only one interface function, and this is exactly the interface function that is behind the start symbol of your grammar. What does this mean? The start symbol contains the complete information. That means the start symbol is created after the whole input is parsed. And then this function is called, and because you have written your own variation of it, you can use the argument in the grammar. So what we can do next? Actually, we want to change the implementation of the semantic triples of the display trait for the semantic triples. This is the data type that Parol creates for the start symbol. And I have prepared this, put this in here, and I will explain it. So this format function prints the start of the directed graph in the form of the graphis dot language syntax. And then it prints for each triple in the list that is parsed the regarding transition here into this syntax. Actually, you have the two IDs, that's the subject and the object, and you label it with the predicate. This is behind this construct. Okay, let's see how this works. Well, yeah, what you can see here, this is the transformed output our generated parser created. And we say that this is now we can have preview for it, and voila, this is the graph. This means everything we had to do is we had to implement some traits, and the complete parser was generated by Parol. Okay. One thing I would like to add is that the parser has several properties. The generated parser can emit errors. Maybe you change here something accidentally and try to compile it, and you will be giving a meaningful error report. Also, one feature called error recovery is implemented in this parser. So you can see that there are several, actually 2 errors are reported. A simple parser would have stopped when facing the first error. So with this help, you can be able to fix more than one error in one. So okay, yes. So what is the overall advantage of a parser generator? Maybe you have heard from or about some other tools called parser combinators. These parser combinators are usually used in Rust mostly, but they have, I think, one disadvantage. You don't have any clue about the overall grammar you are creating. You don't have any information about the behavior of this grammar, and it depends on the input of this on the input that is parsed. How effective is the parsing process? In parser generators like Parol, you have a completely calculated grammar that is melted down into an automaton, and you have information about it. So in this case, our grammar has a maximum look-ahead size of 1 that you can see from the parser. Concluded size of the look-ahead is maximum 1. So in this grammar, you only use 1 look-ahead. So this means you know this property from your grammar exactly. And you also know the problematic non-terminals where your k exceeds a certain limit. So you have properties and knowledge about properties of your grammar. This is a big advantage, I think. Yes, and as I mentioned, the property of grammar, that the separation of grammar description and grammar implementation is given from the beginning on. And you have the possibility to make a prototyping before you really implement the grammar processing.